Hello everyone. In this video we're going to be talking about an open box problem. So here is the problem. An open box is being made from a sheet of paper that is 16 inches by 24 inches and it's to be made by cutting out the corners and folding the sides up. So the first thing is we're going to be writing an equation for the volume of the box. So we're going to be cutting out sides on each one. We're going to be cutting out these squares right here. And whenever you cut out these squares, you should be able to fold the sides up. So you'd be able to fold up these corners right here and be able to create a little box there. So this is the problem that we're going to be looking at here. And what we're going to be cutting out of each side, we don't know what size the box is, but we do know that it is a variable, could be different measurements here. So we're just going to call that x. You're cutting out x of each side, like this. So we have some little squares that are x long and x wide. And then we know that the entire length, or the entire width, is 16 inches. So we know that this whole length right here is 16. So that means that this little portion right here is going to be 16 minus 1x, 2x's. So it's going to be 16 minus 2x. Same thing for the other one, the other length that we're working with. So we have this whole thing is 24 inches. So that means we're taking away 1x and 2x's. So this length right here is going to be 24 minus 2x. Okay, because we're taking away 2 x's, one from each side, and that is going to give us our length and width of our box that we're creating there. Okay, and then we also have a height. Whenever we fold the sides up, this is going to be our height right here. Okay, so this measurement right there. So that means that our height is actually going to be x. That's our height there. Because whenever we fold that up, that is going to create a something that's standing up there. That's going to be our height of our box. Okay, so let's go ahead and write the equation for our box. And the way that our box is going to look now is we are going to have, let's just draw out a box here. Okay, so this is what our box looks like. And you can see that this length is going to be 24 minus 2x. This length is going to be 16 minus 2x. And then we have our height right here, which is that part that we folded up. That is going to be, you can think about it as this length right here. That's just going to be x long right there. Okay, so we have our length right there, 24 minus 2x, width, and then our height, which is going to be x there. Okay, so now we can write the volume of our box. And we're just going to write this as v of x, just like a function. And this is going to be the length times width times height. Length times width times height. So the volume of our box is going to be x times 24 minus 2x times 16 minus 2x. There we go. And this is just the volume of our box. So we're just going to leave it like this in its factored form. All right, now if we want to find the maximum volume of this box, we are going to go to Desmos, and we're going to be clicking on the top point in this box right there. So let's go to Desmos. We're going to be typing in our formula, x times 24 minus 2x times 16 minus 2x. Okay, so this is going to be a very confusing looking graph because it goes up super, super high, and then it's going to come back down to the bottom. So I want to see how high up does it go and how far down does it go. Well, it's going to go up forever after this point, but I do want to see how high it's going up right here. So I can see that it's going up to 540 on the y-axis. So I'm going to fix my domain so that it's going from, I can see all of these points here. All right, so I can see from 0 to 12. I want to see all of that. And I want to be able to see all the way up until the 540, right up there. So I'm going to go to this little monkey wrench tool, and I'm going to fix my axis so that it goes from, let's just do -1 to 12. And then I also want to fix my y-axis so that it's going from, and let's just say -20 to 500, or so we can see 540 to 600 there. Okay, so now we can see our graph a little bit better now. We can see that this maximum point is happening up here at this point right there. This is our x value. That's the size of the box that we'd be cutting out. That's the height there. But then we also have our volume, which is going to be 540. So remember that this was equal to v of x. So since that was equal to it, this is going to be our volume right here, 540. Okay, so let's come back here. And our maximum volume is going to be 540 point, and let's go look and see what it was, 540.829. Okay, and we were looking at inches. Okay, and since we're looking at inches, we have inches times inches times inches, so this is going to be inches cubed. We want 3 inches. And let's just make a little note that it was the y value of the maximum point. Okay, now let's think about what a practical domain for this problem would be. So let's go back to Desmos, and we can see that the x values are going to be the size of the box that we're cutting out. So this would be cutting out nothing from the box, so that would just be a flat piece of paper. And you can see that the volume would be 0, which makes sense because it's just a flat piece of paper. There's no actual volume that can be inside of there. Then whenever you go up to your maximum, that's going to be cutting out a box that is the size of 3, so cutting out the 3 on the side. As you go down, you can see that we get to the volume of 0 again whenever we cut out 8. And the reason for that is the whole length was 16, so the biggest size that you can cut out is 8 on each side because you have to cut out 2 things on each one. We're looking at this box right here. So here is our length or our width. It was 16, and we have to cut out 2 x's. So if I cut out 8 and 8, I'm not left with anything left on my paper. Like, the paper just doesn't even exist anymore. So whenever we're looking at this, our practical volume or our practical domain is going to be from 0 to 8. And you can see that after that, it's going to go negative. We don't want negative volume. And the volume does get positive again after this, but it doesn't actually make sense that we can cut out something that is more than 8. So this is going to be our practical domain from 0 to 8. Okay, so our practical domain is going to be cutting out nothing, but that wouldn't be a domain there. So from 0 to 8. Okay, hope that you guys enjoyed this video. Please let me know if you have any questions. I'll be happy to help you out. Goodbye.